just turn it off. Yeah, okay, yeah.
Welcome in, everybody. We're live.
Oh, yay. All right, cool. We're going to start off. We're charging this battery right here. We're at 12.56, and I'm using a 12 magnet rotor with a north-south configuration. It's 2 magnets thick, and the magnets are like a 1/16 of an inch. Little squares. Got 7.77 volts going in, and we're going to see how much energy we get off the trifilar coil before it goes into the cat bank. So with no more waiting around, here we go.
Whoa.
It's already going up, man. That's crazy.
That was fast. Look at that go.
Yeah, this is good for, let's check out, almost 7 volts are being generated from the trifilar strand. That is phenomenal considering what we're putting in. It's amazing. There's so much energy that is not being wasted. It's all going into the battery. Pretty much.
Mm-hmm. That's awesome.
See, but if I turn it, if I keep cranking it up, our return is going to start being less. So I think we're at a happy spot right now. This, I could run a relay on this for like, weeks on these 2 batteries.
What's up, Mikey? Long time, Mike Nettle.
What's up, Mikey? Yeah.
Holy smokes, how are you doing, brother?
Or we're all the way up to 12.61 on the battery.
Dude, that's going fast. Welcome in, Angel. Welcome in, Michael.
Hello, hello.
We are running with pulse motors today. Thank you for dropping in. Let us know if you have any questions.
I'm going to leave that. That's pretty. I like that. 1.1, 7.77.
Numbers. That's a good sign.
Mm-hmm. And that's what's going in. So, I don't know. Let's flip this over to the amps.
And then when does it take from the battery? Oh, when you switch it on.
Yeah, it's not taking from the battery right now. Any of the batteries. I'm just charging the battery up right now.
We are working with electromagnetic experimentation today, and we're taking readings.
So you got to understand that when I hook up the relay and I hook both batteries up and you're actually spending from the batteries, they're both going down. Even if they go up, they're both going down. And that, you can see that right here. It's going down, but it's going down very little.
And then how much can this take?
It can go up to like 13.5 maybe.
Okay. Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a like, subscribe, let us know if you have any questions.
But yeah, I mean, and it's this easy. Actually, I'm gonna have to cut this down. We can go up higher when I turn it back on. Okay. power's off, we're still generating 3 volts. So like, you do the math on that, we're getting like 3 volts from the magnet spinning. And then the rest of that voltage, the other 3.5 volts, was transformer action from the coil being a trifilar. But since it's on a pot turner, the power supply, I don't have like a switch that dumps it all at the same time, because then you could really see exactly how much is being generated by the magnets, because it would stop out all of it would stop at the same time. And then the battery goes down a little bit, but that's okay. And what we're gonna do, we're just gonna swap it like this. We're gonna monitor this other one. All right, that one's at 5.4, so we're gonna charge it up a little bit.
You can hear that hum.
Okay, 9 volts at 1.4 amps, 1.3, 1.4. And see, the differential is a lot more now.
Oh yeah.
But everything's working, humming at a higher tune. So I'm gonna turn it back down, because that is gonna start to rattle. So I'll turn it like 7.7, where it was before. And even that 0.07 that is not on there, it shows on here as 0.05, because it was 0.96. Now it's 0.91. So even that little tiny bit is 0.02 of a difference. So it scales all the way down to the micron that you're gonna get less than what you put in.
Thank you for the likes. We appreciate you guys. Thank you for dropping in.
Well, I mean, I do these experiments, and this is what it turns out to be. And then the amperage, I just cranked it over to amps coming through the cat bank here, or no, the trifilar. Here we go. And that's DC amps, 0.016. Terrible, right? Terrible. Considering we're spending 1.1.
Got it. Yeah.
So, I mean, it's definitely not equivalent by any means.
Hey everybody, thanks for dropping in. Thank you for the likes. Let's see if we can get the likes up to 10. We appreciate y'all.
Only in the area of the voltage is it like really good. But I need, if I had an analog amp reader, it would probably read something different than what this meter is reading. I have a feeling it's going to be a little bit less, because it's not a 1-to-1 transformer. It's 18 gauge to 20 gauge. The only part about it that's 1-to-1 is the size. So the length of the wire is 1-to-1, but the gauge is not. It's not. You're going to get less on the 20. If I had two 18 gauge strands in there would be like a more accurate, but you're getting more voltage, I think, this way than you would with an 18 gauge strand as the trifilar. And it's just because I think you're going to get more voltage with the smaller wire, the thinner wire. You're going to get more voltage, and then you're going to get more current going through the thicker wire, but you're going to get less voltage. And the generator is part of the whole thing.
All right, everybody, let's get 5 more likes up there. We appreciate you guys. We got 50 people watching now. Let's see if we can get 250 up in here. And you guys help do it. You definitely help do it. Hitting those reactions and those likes. Let us know if you have any comments.
All right, so we've got, this battery was at 5.4, now it's at 6.1.
Okay.
But I'm gonna take, well, I'm gonna turn the power off, and I'm gonna take, yeah, we're still generating like 3.5 when I get the power all the way down.
Thank you for the like. Appreciate you guys. Let's keep it going.
Let's see how much energy we retained, if any. Okay, we're fluctuating between 5.7 and 5.8. Oh no, it's not fluxing anymore. It's 5.7.
Which is 5.7.
So that's 0.02 that is stayed in there so far, what I've generated with all of this.
Thank you for the like. We appreciate you guys.
But the batteries are pretty full and might be rejecting, some of the energy that's going into them.
Hola, Rickard. Thank you for dropping in.
Hello.
Yanni, welcome back.
I just love how this one is so smooth, man. It's great.
Yeah, it sounds smooth. You really get the acceleration sounds with this one.
Yeah, it's kind of a thrill.
Mm-hmm.
A bit.
Hit the like if you like balanced equipment that gives good data and experiments. Sorry.
Oh, now we got hooked up to 2 different batteries. I got excited and I turned the power back on. Oh, I don't want to do that. There we go. All right, so if I hook up another coil, and we gotta get the right coil going here.
Thank you for the like. Appreciate you guys. Let's get it up to 10. 2 more. Let's do this.
But then I'd be running this thing at 12. And this rotor definitely can't run a relay. There's no way. It costs too much to run this rotor. Like I was saying, it's definitely over an amp to run this rotor with 1 coil. Let alone 2 coils, it would probably cost, 1.6, 1.75 amps to run altogether. It's a lot. That's a lot. Yeah, 3.5.
Right, that's low volts. That's awesome.
Yeah, and we're still getting good generation. Oh my God! Except for the amps. If the amps were lower, our voltage is actually higher than the voltage going in. But it's AC voltage.
There we go.
And that's DC voltage. Can't really get an accurate reading on the DC side of this thing unless what I have to do is disconnect the battery connection. And hook up gonna hook up the clip multimeter. All right, there's the DC side of that. Oh, there's a lot of cap banks and everything, but this is basically what's coming out of the cap bank. Without the load though, I disconnected the battery because once you connect the battery kind of takes over what the reading is. If you get what I'm trying to say, the reading is now what the battery is and not what's coming out of that.
Hey everybody, welcome to the channel. Thank you for dropping in. This is Papa Bale. We're hanging with Pulse Motors tonight. Let us know if you have any questions. It's getting close to prime time here on the East Coast. Let's see if we can get 150 people up in here. Like and subscribe if you like this kind of content.
1.86 volts, 0.1 amps.
That is low rider.
But we are definitely, it's enough to, because it's got a cap bank attached to it. And there's bridge rectifiers. We got 28, 23. It's going to start storing until it reaches the point where it's like it starts pushing back and it won't go any higher.
What size is the shaft? This one.
1/4 inch.
This one's a 1/4 inch.
But here, let's.
Okay, he said Vance commented, one important improvement I can see is the batteries used are for fast depletion. You need a deep cell for slow output.
Yeah.
10 likes. Thank you guys so much. Appreciate you. Keep it coming. Let's get it up to 20.
And yeah, we're at, as soon as I connected that, we went from what it was to what the battery is. So that is what I thought would happen. But now at least that energy can go into the battery. Here, let's do that 1 point.
Hey everybody, welcome in.
So it was like, it was 3.5 at 300 milliamps. Got us 3.7 volts over here. So, but it was only, we're only getting like literally like 15 milliamps generated. That this meter can read, you know, that I don't have, you know, what I would consider legit amp reading equipment.
Yanni said he got 1 to 1.5 watts from cheap pedestal fan using the rotor as the flywheel. And that shaft is the shaft. Okay. Nice.
Sweet. 1.5 watts.
1 to 1.5.
Okay.
And he was out. Yeah, that's a result. What's up, SAQ?
So,
This is twice today, so we're setting records. Bring it on.
all right. I mean, we're getting phenomenal. You know, thing is spinning pretty fast at for 1.6. But we want to pull some amps, a little few amps. We're gonna get a little bit of a rotation going. Okay, so we want to check this thing out. I
This
think we can
guy?
check it out.
We're checking out this guy. Yeah. Have a good night, SAQ. Thanks for dropping in.
Good night, man. Oh, did I not light up the right one? Oh no. I can't mess with this thing right now. Yeah, let me turn that switch off. Gotta charge up all the batteries nice and good. I've been playing with that thing all day and it works really good when the switches are right. But you gotta adjust them because, you know, it's a copper wire. Uh, and I gotta make. I wish I had two of these coils. These ones right here. That would be sweet.
Hey everybody, welcome in. Thanks for dropping by. This is Papa Bale.
What's up, everybody?
Let us know if you have any questions. Like and subscribe if you appreciate the DIY content.
And then I would set up a relay that makes sense. And then I get, you know, 4 more cores, make it, you know, symmetrical.
What are slip rings? I don't even know. Yanni said that thing is awesome. It needs slip rings. How to wireless transfer to power externally, dynamically, the electromagnets. Wireless, so no need for slip rings would be cool.
Oh yeah, man. Hey, look, man. I've been like fantasizing about Tesla coil being able to power this thing through resonance and yeah, and just get it moving that way. But the receiver, it's got to have a receiver, and I don't think these coils are designed to receive that frequency that a Tesla coil would produce. So there'd have to be like some sort of happy medium where I make a coil that um, would wirelessly. I don't know. And I might be totally wrong about that. Like if they don't have to match up, um, then just being in the field would probably be good enough. But I'm pretty sure that in order to get the big bursts or the steady, it's more like a steady flow of energy that is triggered when the switches make contact with because it's got to be timed. It's got to be timed, and you got to energize. There's got to be some sort of receiver that receives it and acts like takes place of the batteries. Because it's got to be energized like that because it's being timed by a very mechanical operation. But yeah, man, I've been searching for a way to make it happen that's practical. That isn't so obscure that like a Tesla coil, and then like something that would receive the energy from the Tesla coil is placed on the rotor in place of the batteries, and that would take a lot of weight off of it. That you're right, man. That would be optimal. And I keep on throwing it out there, like there's got to be somebody who knows a way to do that.
He's like, yep. Something to think about. Cheers.
Because I got this little coil, Tesla coil thing up here. It's not a homemade one, but pretty cool. Little record player.
The Tesla coil.
Then it makes plasma, but it doesn't. It's not enough to excite a pulse motor by any means. Not this little one. Let's hope I can get it in the slot. Hey man, why don't you jack up real quick?
Mm-hmm.
We'll get some iron powder out here real fast after I plug this in. Oh, it's gonna work.
Sorry about that. I'm trying to zoom in.
Well, that's kind of startling. Want to kill the light?
Mm-hmm. Wow.
Pretty sweet.
Yeah.
That little needle got hot. You can see it can turn orange.
Yeah. Yeah.
I put my hand in that before, and it's just a little poke. It's nothing like major. Even when it's full blast, it's like not bad. Because the frequency is, just to generate that, is I think pretty high.
Mm-hmm.
But then it's pulsed at a lower frequency, as you can see. It is.
Right.
That little thing is pretty cool. I know I cheated. I bought one, just a little baby one.
Mm-hmm.
I bought it like 3 years ago, but I mean, before I was even knew I was going to be doing this stuff, I bought the Tesla coil because I thought they were cool.
I think, yeah, that was cool.
And then, you know, you can light lights and stuff like that, LEDs. I tried to I put it in the drive of my pulse motor, like right up next to the copper wire, and the plasma literally like shocked just the wire. Like every single tentacle of this thing was like just shocking the same spot on the wire, and it wasn't enough. It didn't work.
Mm-hmm.
And I had it like right up in it like this.
Mm-hmm.
But you know, I wouldn't consider this to be like too tremendously high voltage either. It's just a toy. But it's fun. I like playing around with that stuff. All right, let's see what this one looks like. We did the cubes earlier with the 2-magnet rotor. Got our iron powder.
Hey everybody, welcome to the channel. Thanks for dropping in. This is Papa Bale's Pulse Motors. We are running some electromagnetic experiments. Check this out.
It's pretty sweet.
Wow. That's like art on its own. Like and subscribe if you like this kind of content.
Wow, that's so fun. Haha.
Wow.
Yeah, right up on See, like right, like on the magnets is like a 0 point. You know, like on the edge there, there's like no magnetic activity whatsoever. But on the right on the other side of that, there's a lot. There's a lot. That's so sweet. Sorry if I startled anybody. I startled myself. Sure. All right, that's fun. That is too fun.
Yeah, I love that too. That is really cool stuff. Hey everybody, thanks for dropping in. This is Papa Bale's Pulse Motors channel. Please like and subscribe and let us know if you have any comments or questions. Nice work.
Every time I do that, we lose a little bit in residue. Whatever the iron is mixed with, it gets stuck on the plastic. So I think it's a good thing, honestly. And I make cores with this material. I don't know if that's a good idea or a bad idea, but it works just the same.
Iron filing.
Yeah, iron filing. All right. Spent a nice long while at the pool today.
Nice.
Yeah, got some color on my skin.
You got some sun. I need some sun.
Just a little bit though. Just a little bit of sun. Oh man, I am hungry. At the same time, like not really hungry.
I am also hungry. And tired at the same time.
Oh, hungry and tired. That's a bad combo. Well, I mean, like if you can go to sleep before you eat, then it's a good combo. All right. So, I don't know. We're just we're charging. What are the battery? What does it look like?
These are off.
They're off.
Yeah.
Oh man, because we're sitting here charging a battery. I don't know how high it is getting. It's all of this one, so let's check it out.
1258.
Yeah. Doesn't. Oh, and we're at 3.1. Okay, we're so low that that's actually pretty good. I didn't realize how low the voltage was because of how fast it's going. It's like, normally it doesn't go this fast at such a slow speed. But I usually work with like bigger rotors too, like this one down here.
Oh yeah, that one's been on the channel a lot.
That's a 14-incher.
A 14-inch.
Yeah, 14-inch with 12 neodymium magnet that are powerful, man. These magnets are powerful.
Is that what your dating profile says?
These magnets are powerful.
Yeah.
Phenomenal.
Hey everybody, thanks for dropping in. Welcome to the channel. We appreciate y'all. Thank you for the likes. Let us know if you have any questions. Drop by the channel, check out some videos, subscribe.
I would never lie to you and say this is hard to do. Okay? I would never say, hey man, this is the hardest thing in the world to do. Not at all, man. This is easy. It's easy to do. You just need to know where to connect what, and sometimes what to use to connect something. You know, it's like, you know, me, I was really dumb when it came to this stuff. I didn't know what the connectors were called. I didn't know, you know, what was with what, and so I couldn't even buy the stuff that I needed because I didn't know what it was. Okay, and if you have no idea, anyway, I searched the rabbit hole of Amazon to get some stuff that I needed, and then like all the other sites that are basically obscure, they're better sites. I'm not saying that they're not better; they're just obscure because where are you going to get the information to find out where these sites are called and how to get to them? And it's like Google would be a great place to start. So you get all your data, and this is all about connectors right now. I mean, basically, you know, it's such a vast, there's a vast array of connectors. You have, you know, you have alligator clips. You can use those to connect things. You got the big alligator clips. You've got these things. These are connectors. They're basically clips. Anything that can clip, you know, two wires together is a connector. Like the Eve distribution block right there, where the power's, that is basically a terminal block that's a distribution block. It's basically another clip. You just can clip everything to that. You screw it in. Just another clip that basically distributes power. So it's basically a very specific kind of clip in that regards. But you know, once you get everything down, it's pretty simple. What this is, and then like you branch from what you know. You take what you know, and it's right. I need to get the paper. Okay, if you know pulse motor, this is a pulse motor right here. You got your switch, you got your coil, you got your power supply, you got your rotor. This is your basic. You go from here to a trifilar coil or a bifilar coil. And then you go from your basic switch to a transistor right here. And you know, this is how easy it is right here. And it's so much fun. I wonder why more people aren't doing it. You know?
Right?
As long as your design is sound, and I gotta tell you, you need to have your magnets be basically encased. They shouldn't be wobbling around, and you should definitely like if they're. Let me try to explain this. You don't want plastic in the front of the face. You want your face to be open, not yoked by any. Like this rotor is a good rotor because it's got all the holes where they need to be. And you can kind of see how it's shiny on the side because I made holes so the face could, you know, there would be no magnetic interference.
You can cut like it's going so fast, but you can kind of see that there.
Like this one right here, these electromags are yoked because there's like a 1/4 inch of plastic in front of them. So they got to get, the magnetic field has to get through that plastic. And it trust me, it knows it's there. The magnetic field knows that the plastic is there. And it's like, why didn't you make a hole for me?
Mm.
Why'd you do this to me? Because I was meant to be great. And you took me, you cut me off at the knees. Why'd you do it?
The magnetic field is laying a guilt trip on you, Lane.
Yeah, it made me feel bad that I didn't make a hole for its core. See, and then like another thing that I was gonna do is I was gonna make a contact plate, like make a hole in this triangle. There's a triangle formed by the holes. Like if, later on you can get a good look at it. But I was gonna make a hole for and then put a contact plate in the hole that would touch the core of the electromagnet and the shaft. Okay, and then it would electrify the shaft to the contact plates.
That's interesting.
And then the shaft could play a bigger part than it does right now, because all it is there is to stabilize and center everything.
That's right.
We could use it as a conduit for energy.
Then you can spread mass healing.
But it's not about like the theory and exactly how do you do that. And I thought, the contact plates, you would connect the coils somehow to the shaft through the plastic. And you'd have to drill a hole or make a hole and then have like a solid piece of copper in that hole. So you drill a hole the size of the piece of copper and you just shove it in there. And then it would make contact with the bearing and the coil, or the core in the coil is basically what it would make contact with. See, yeah, I don't know, man. It's like, that might not work now that I think about it. Because the core only transfers magnetic energy. It doesn't transfer the actual electricity. Magnetic flux is what it works with. And you'd actually would need current to touch the contact plate in order to electrify, quote unquote, electrify the shaft.
Do like a crane on long deck. They set on plates.
Yeah, I would dance a jig with the plate on my knee, eat my supper, and then and everything would be fine. I wouldn't break a single dish, so I'm all right. I'm cool.
Crane on log deck. Okay.
Oh yeah. And then we were talking earlier about making little compartments in the rotor for the batteries, so that they wouldn't fly off or fly around. And we would just have to make a new rotor. And there is a problem with this rotor. This is a very small problem. There's a 1/16 of an inch gap for each coil, because I made it 1/16 of an inch too long. The hole is too long, so there's room for this thing to move back and forth. There's 1/16 of an inch gap there, so I need to redo it anyway.
Got it.
But I think these coils are good.
You may redo the 3D print.
Yeah, redo the rotor.
Okay. How does That's. I was just going to ask you that, Randall. Okay. And it's a crane at a sawmill,
Oh, I see.
like an actual crane and a log deck. So that's.
Gotcha.
He said that's how they work. What you're talking about.
Okay.
We'll check it out. Thanks, Randall.
Wow, man. Like the sun, like I'm in such like a comfortable mood. Sun just kind of blew me out. Whew. I was looking at some of my old videos today, and then I use a transformer, this little bad boy right here, a lot in my older videos.
I remember that guy. What's up, brah? Welcome in. Woo.
Wow, man. The neighbors are gonna call the police, man. They're gonna be like, what the hell? Oh no, that's so fun. Man, I used to have all these like toys that went with it too, like thing that would spin on the top and like shoot colors out the side and everything. I had one of those. I had like a little comb thing that I could like plug LEDs into and light them all up. The cool thing is that I think it lights up all the LEDs that I could plug into this thing equally.
Hmm.
And that, yeah, I don't know, maybe it was producing enough to do that, which is okay. But I don't, like, there's so much about it that I don't know. But I don't know if it's supposed to work like that. Like if you put, like for flow bulbs, if you put 10 flow bulbs up against one Tesla coil, it'll light all those flow bulbs up equally.
Hmm.
And I don't know. I mean, in my mind, it's like, I don't think it could, but I don't know how it works, so I can't make a proper assessment. I've seen Tesla coils do miraculous things. The transference of energy and resonance to everything from mud to lead to fruit to just basically anything, wood, water, and I've seen Tesla coils run a motorized speedboat of a toy nature, about yay big,
Hmm.
little toy boat, and it remote controlled, powered by 2 Tesla coils in the ground. And it was, I'm like, yeah, that's what I want to see. There's definitely some sort of receiver there that we could work with. to do miraculous things. And I thought that video was really, really cool. I'm trying to remember. It was a documentary of some kind. Well, I'm not exactly sure. I believe it was Tesla, a Tesla documentary, and they used two 25k watt Tesla coils, and they did all the ground stuff. They powered the motorboat. They did a lot of things with these Tesla coils that I thought was really cool.
He said that's something that Tesla actually did, powering the boat.
Yeah, no, I think you're right. I think this was a demonstration of that experiment.
Okay.
It was, yes.
Calls it KVA. I'm not sure what that is.
The three guys that redid the experiment, I think they did a really good job. And yeah, man, I mean, if I could get my hands on, just a Tesla coil and then one of those things that made the boat run, or three of them, three of those things that made the boat run, and then we'd be good, man. We'd be solid. And I'll hook one of those up to each one of these coils via the switch on each one, and bada boom, bada bang.
Bada blam.
Might need a cap in there or something to like store energy, have enough, but it would be constant. I don't know if you need a cap though.
Energy, frequency, and vibration.
Sounds like the sequence for vibranium.
Vibranium. Yeah, my body gave out 20 minutes ago, bro. I'm sorry.
It's okay, man. I feel the same way. It's all right. I've turned off stuff. I can't believe that this is only like 3 volts, man. This is crazy.
Yeah, it's
moving that fast.
Still going.
So I gotta just accept that my situation is never gonna be optimal, and it's obvious that it's because I want it that way. I'm never gonna have 2 coils that are exactly the same. Okay, it's never gonna happen because every coil that I make is different.
Mm-hmm.
Okay, so we're never gonna have 2 coils that are exactly the same, which turns a lot of people off automatically. It's like, huh? What now?
It'd be like, that's too easy. It's too easy.
It's too easy.
Yeah.
I don't know. Yeah, it's too easy to have 2 coils that are the same, man. What are you trying to pull?
Exactly. That's
You're cheating.
That's weak sauce.
We may or may not get this other pegboard up here. We've been talking about it for months, and I just I don't have the strength. Well, that's not exactly it. I don't have it's not even really laziness. It's just a lot of work. And I don't know if I have all the components that I need to rebuild it if I take it apart. So I gotta take my time with it. I gotta make sure that I need wood glue. I'm gonna need either some bolts, some 1/4-inch bolts, or some 1/4-inch screws of some kind. I already have those holes drilled in here. And then they would go like all the way through and hold it on to the frame. And I could make connections with these bolts underneath the table. So like if I wanted electricity to travel along or across the table, I could use the bolts. It's not the best solution. Might not even be a solution, but I think it would work. I think if I took the batteries right here and I clipped them to two bolts right here, that I could then clip the bolts to, whatever I was powering, and it would run. Is it the best conductor? Probably not. But of course, I'm just, I'm trying to make the table more intricate.
Later, Randall. Thanks for dropping in. We'll check that out. We'll hit you up.
Yeah, and then for sure. I don't know, like I was talking to somebody and they were talking about making a whole table that had adjustable coil slots and everything on it. I'll buy it. I will buy one of those if you want to build one, and I think it's cool. It's easier to use than me doing what I do. I will buy one. Straight up, because I've been trying to find a way to do that since I started. Besides using glue, and I haven't been able to really like find a good way to do that except making the coils heavier. Like, see this one, nice and heavy, man. This one's got to be like almost 2 pounds. No, I don't know, pound and a half. All right. You good? We good?
Yeah, let's call it.
All right. All right, man. Well, thank you very much, ladies and gentlemen. Peace out. Have a wonderful night. And we'll get back to doing this. I'll probably set up a relay, find out which rotor I'm going to use. I'm probably going to use the 2-magnet rotor, set up the relay for our next live stream. All right. Thank you very much. Peace out. Bye now.